Three notes, guys. Now we're moving to two-step equations, and we're going to do a couple word equations for inequalities. Okay, so this one here, x over 4 plus 3 greater than 8. Use algebra and number line to show your solution, then verify your solution. So what we're going to do first is we got to solve. So we're going to go minus 3 there. Okay, minus the 3, minus the 3. Why are we doing minus 3? Because remember, you've moved the thing that's farthest from x, and you always do addition subtraction first. So that's going to give you x over 4 greater than 5. Okay, remember that's just a dividing bar. So we times the 4 times the 4. We get x greater than 20. It says use algebra and a number line to show your solution. So we're going to use our number line. We have 20 here. We have greater than, so it's open dot, and we're going bigger. Okay, and we're going to use algebra and our number line to check it. So for algebra, we're just going to pick a number like 21, or let's go with something divisible by 4. Let's go with 24. So if I go 24 over 4 plus 3, is that greater than 8? 24 over 4 is 6. 6 plus 3 is 9. That is greater than 8, so we just verified it. Okay, 24, 1, 2, 3 is right here. So we are feeling good about our answer. Okay, we just verified. Okay, so we already showed the solution on the number line. Check the boundary point 20. Check the value greater than 20. So we already checked the value greater than 20. Check the boundary point 20 itself. So if we check the value point 20 itself, what's 20 divided by 4? 5 plus 3 is 8. 8 is not greater than 8. Okay, so that would not work. 8 is not greater than 8. Okay, we don't have equal to. Okay. Well, all right, so that's that first one. So we'll keep going here. Minus 11, 4x greater than 24. Divide by 4. Divide by x greater than 6. So in terms of a number line, you just draw your number line here. Just put 6 on it. It's an open dot and greater than, so we're going to the right. Wants me to check it, so let's try 10. 10's bigger than 6. 4 times 10 plus 11, is that greater than 35? 4 times 10 is 40, plus 11 is 51. That is greater than 35. So we just verified that we have the correct solution. Again, don't be lost. We're just solving normally. We know how to solve this as an equal sign. You still solve the same way. We haven't ran into flipping yet. We haven't divided or multiplied by a negative. That's the only thing we're looking out for. Okay. Otherwise, you just need to know your definitions and how to read your inequality symbols. Okay. Open dot, close dot, that stuff. Okay. Any questions? Okay. So let's do the one part B here. This one's similar to the one we did in our example. So again, add 5. Add 5. X over 2 less than 12. Times 2 times 2. X is less than 24. Okay. Are my symbols the same as yours? Are any of them equal to somewhere and I'm not getting them? They're all the same? Okay, just want to make sure. Sometimes... Well, sometimes mine forgets the bar on the bottom. I don't know why. Okay, so let me know if it does. So x less than 24, so we have 24. You just post that in the middle. Open dot to the left, less than. We're going to check that. Let's try 30. Or no, 30 is bigger. Let's try 20. 20 over 2 minus 5 less than 7. 20 divided by 2 is 10. 10 minus 5 is 5. 5 is less than 7, so that is confirmed. Okay. Pretty easy so far. Now what? Now what do we do here? Okay. Yeah, so this is the same problem some of you guys ran into with chapter 6. Okay, now we have to get our x's together. Your first step is get your x's together. We move the smallest x. So it's a negative 3x and a positive 5x. You guys okay there? Somebody smell or what? Easy, easy. Okay, so that's our first step. We added the negative 3x over. Why the negative? Because it's the positive. Okay, you can move the other way if you want, but then you have the negative issue. And especially with inequalities, we really like to avoid the negative issue. Okay, what I mean by that is, if I move this over, the 5 over here, I'll have a negative 8, and at the end, I'll have to divide by a negative, therefore I'll have to flip the inequality. It puts out one more thing I could mess up. Okay, so just now we just simply minus 38, negative 48, divide 8. This is not a flip situation. Negative 6. So it's negative 6 is less than or equal to x, or you can rewrite it the other way. X is greater than or equal to negative 6. Those mean the same thing. Okay, so again, draw our number line, put negative 6. It's a solid dot on negative 6. And it's going to the right. So an easy one to try would be 0. Okay, because 0 is bigger than negative 6. If I put 0 in, it essentially gets rid of your variables. Is negative 10 less than 38? Yeah. So if I try 0, so if I try 0, those go, those go. Shh, guys. Shh. If I plug in 0, it makes a true statement. You got a question, Connor? Are you good? Yeah, so I got greater than negative 6, right? 0 is bigger than negative 6. That's a really easy thing to try. So I put 0 in here for the x's. And so those just go away, right? Because it's 0. So negative 10 stays. That goes away. 38 stays. Negative 10 is smaller than 38. Okay? Cool. Keep asking questions, guys. Stay with me. Again, work on the side chatter. Start moving some of you guys. Shh. Gotta stop the side chatter. You guys are talking too much. Shh. I would say it's you, Parky, right now. Yeah, and that's on. I recorded that. It's on the video for everybody else to hear. Okay, so solve the inequality. So again, the x is the problem. They're on both sides. Again, move the smallest one if you can. It's easier if you do that. Because we don't care what side the x is on to solve for. It doesn't matter. So add 2x, 5 greater than 12x plus 29, minus 29, negative 24 is greater than 12x. Divide by 12. So you don't have to do their steps. They're moving stuff to the left. We're going to avoid that if we can. Negative 2 greater than x, or x less than negative 2. Either works. So if we graph that, less than negative 2, open dot to the left. Try something like negative 5 maybe. So 5 minus 2 times negative 5. That's a greater sign. 10 times negative 5 plus 29. Okay, so negative 2, so like this right here is like a negative 2 times a negative 5, which is a positive 10, plus 5 is 15 for this spot. And the other one is negative 50 plus 29. Is 15 bigger than negative 21? It is. I tried negative 5 is what I tested. Negative 5's over here, right? Okay, questions? All right. Okay, this one, move the 3x, that's a smaller x. So minus 3x minus 3x. It's gone. 3x minus 4, less than 8. Is it equal to on yours? Yeah. It is? Okay, so it's equal to on yours. Add 4. Divide the 3. X less than or equal to 4. So if I draw that number line, solid dot, less than or equal to. Something smaller than 4, always try 0 if you can, in my opinion. It's the easiest number to try. So 6 times 0 minus 4, less than 3 times 0 plus 8. So essentially, it's going to be gone, gone, negative 4 less than 8, correct. Negative 4 is less than 8. Yeah, Kel? Both x's have to be the same value. What would you plug in? Yeah. Yes. When you plug in something for x, you plug into all your x's. Correct. Good question. Anything else? All right. Okay. All right. So this one, a step further. So now we have the distribution. So as you can see, what they're doing in this section is they're taking all of your harder solving questions from we did earlier and putting them with inequalities now. So now we have to distribute the negative 2. Negative 2 minus 6 less than or equal to 10x plus 18. We'll add the 2x over. Minus the 18 over. Divide the 12. Either of those work. Negative 2 less than or equal to x, or x greater than or equal to negative 2. I'll walk through that. I know I went through that quickly. Sorry, the solving just kind of keeps falling pretty quickly. So I added the smallest x first. Okay, so that's gone. 10 plus 2 is the 12. Next thing I did is I moved the 18 away from the x. I'm trying to get the x by itself. Minus 18 minus 18. I owe $6. I borrow 18 more. I owe 24 now. 12x is greater than or equal to negative 24. Divide the 12, divide the 12, you get negative 2. So in terms of a graph, got your negative 2, and it's greater than or equal to, so solid dot to the right. Okay, and again, I could try 0, so I'm going to try 0 here. So negative 2 times 0 plus 3. Okay. So 0 plus 3 is 3 times negative 2 is negative 6. 10 times 0 is 0. 18 is 18. Negative 6 is smaller than 18. Okay. All right. Okay, so it's got the 2 show you knows here. You can kind of ignore, like this right here is just them doing the step for you. They're just trying to help you out. So 4 times x is 4x. 4 times negative 2 would be negative 8. Is greater than or equal to 5x minus 12. Move the smallest x again. Negative 8 greater than or equal to x minus 12. Add the 12. So again, you can kind of get rid of this. We're doing our own. So 4 is greater than or equal to x, or x less than or equal to 4. Okay, so it wants us to check the boundary point. So that means it wants us to check the 4, which we can use the 4. So for this example here, it'd be 4 times 4 minus 2 greater than or equal to 5 times 4 minus 12. 4 minus 2 is 2, times 4 is 8. 5 times 4 is 20, minus 12 is 8. 8 is greater than or equal to 8, so that is correct. So we check a value less than 8. If you checked one less than 8, you would get it wrong, because, or it wouldn't be allowed. Because if you try, let's try 0. 0 is the easy one. So if I put 0 in here, I'll just do it kind of out loud. 0 minus 2 is a negative 2, so the left side would be a negative 8. There you go, the right side. If I do a 0, that's just gone. I get negative 12. Sorry, we had this flip, don't we? Yeah, sorry. We do have less than 4. Sorry, we're good to do. It says try something less than, not 4. Excuse me. No, we didn't do it wrong. The only thing we did is we checked the actual boundary point, and it was true. But we want a value less than 4, because that was our answer. I just didn't write our answer. Our answer is 4, not 8, because 8's just what we got when we checked the 4. So that doesn't make it the answer.
And you can check 0 too.
Yes, because 0 is less than 4. Yeah. Well, where? Here? Yeah. So for this right here, yeah, technically yes. Right. Okay, and so then this one right here should be flipped too. Sorry about that. Because we already had the answer here. Okay. All right, so this last one here for this section, and we're going to get to the word problems, I believe. Okay, so we'll distribute. Okay, we have 3x and 7x, so we'll move the 3x. Minus the 19. Divide the 4. Both of those are the solutions. Greater than or equal to -1, or -1's less than or equal to x. So we can graph that. Do -1, solid dot to the right. So we can try 0 again. If we want to test something. 3 times 0 plus 5, less than or equal to 7 times 0 plus 19. That's 5 times 3, that's 15. 19. 15 is less than 19. So as you guess, 9-3, like for this big chunk of it, it's really not super hard if you remember how to solve. You just have to look out for that one negative issue. But with all these examples they gave us, we just kind of made sure we kind of avoid the negative issue because we moved the smaller x. As long as you move the smaller x, you won't have a negative x, therefore you won't have to divide by a negative. Okay, but remember, if you ever get in a situation where you did get a negative x, you're still fine. Just remember when you divide by the negative, you got to flip the inequality sign. I've been saying that for 3 or 4 days now, so let's make sure we don't forget it. Okay, so this is where you guys are going to struggle. This is where you're going to want to make sure that you're paying attention, because you have to be able to build the inequality yourself. It doesn't tell you what the sign is. It doesn't tell you how to write it. You have to do that yourself. Yeah, go ahead, Tor. Okay, so 2 stores want to hire Sarah. Store A pays a flat rate of $55 per day plus 3% sales. Store B pays a flat rate of $40 per day plus 5% of sales. How much does Sarah need to sell for store B to be the better offer? So we want to write an equality. Okay, we're going to write an equality to set this up. Okay, so pay attention. So how would you write that as an inequality? Let's just do it in terms of A and B. Yes. How would you write it?
0.03, you can say as for sales plus 55.
Okay. So 0.03 S, sure, plus 55, okay.
Is less than or equal to?
Okay. We want a better deal, so it has to. It can't be equal to.
Oh yeah, 0.05s plus 40.
Okay, good. So with that, he's correct. So what he's done is he's written it out so that the store B is the greater than. Because we want greater than for B because B wants to be a better deal. You can flip the whole equation, absolutely. And that's how I probably would have wrote it. Okay, I would have wrote it, like first off, if we're just doing a simple one, we want store B to be bigger than A. Right? Simply, that's what we want. We want B to be the better deal. Well, better deal for you is which one you make more money. So we want B to be bigger than A. So he just has, this is B right here for him. This is A. If you're saying, where am I getting to B and A? Read the question right here. B and A. Okay? So now we have to solve it. Does that make sense? Okay. I'm also going to switch to X's just because my S's are pretty ugly, so which they're too much like 5s. So X stands for sales. Okay? Identified your variable. Okay, so I'm going to do just like he had it. I'm just going to flip yours, Aiden, that's all. I'm going to write this on the left, okay? So 0.05x plus 40 is bigger than 0.03x plus 55. So what's the smaller x, 0.03 or 0.05? 0.03, so that's when we're going to move. So I'm going to minus 0.03x, like that. That's gone. 5 cents minus 3 cents is 2 cents. Okay, the key is, and then I'll explain it again, the reason it's not equal to is because it says better deal. We want better. So if you're equal to, that's not a better deal, it's the same deal. Okay, minus 40. Divide by 0.02. Okay, so in order for B to be the better deal, 750? Thank you. You have to have $750 in sales in order to work for like option B. So just let's be clear here. If you, so what that means is if I sold 200, which is a better deal? A, right? So A starts out as the better deal, correct? Because you get more money up front. Let's think about this long term. A is a better deal right away because you get the $55 instead of $40. So you're already $15 ahead, right? Yeah. So we're trying to figure out when it's a better idea to work for store B. That's essentially what we're doing. Okay. At $750 in sales, if you can do that or more, you should work for store B. Okay. If you're going to be weaker in sales and be in the 200s, you should work for store A. All right. Okay. This next one, I want to see if you can try to set it up. It's not expensive, it's how much you get paid.
No, for this one.
This one?
Because surely you can just put one out.
Let's see here. So Danny owns a computer repair business. He offers his customers 2 payment options. Option A, $40 plus $8 per hour. Option B, no fee, $15 per hour. How many hours does a repair job have to be for option B to be less expensive? No, because option B, let's see here, 42, yeah, so, no, you're right, it'd be option A. So they want, actually, Connor, they want to know the breaking point. So how long until this is not a good deal anymore? Because $15 you're fine, but it's growing faster, right?
No, I just said, and then how many hours until option B is less expensive?
Yeah, so I guess that's right, yeah. Yeah. What would be the cost for what?
So it would just be 8 and 15 per hour.
Right.
You wouldn't write.
Yeah, you wouldn't write. You would just go, so fee option A, fee is 42, cost per hour 8, and then n hours is just your variable. So you just keep it, it's just n. So like you would write, they're just writing it all the way out. 42 plus 8n. This one, option B, is 0, 15n. So you're simply 15n is your equation for that one. So we want to know, when is 15n cheaper than 42 plus 8n? That's what we're trying to figure out. What's wrong, Duffy? Got a question? Okay. Okay, so remember, we're getting it from up here. There's two payment options, $42 plus 8 an hour or 15 an hour. We're trying to figure out, and it's a little bit of the wording, like Luke said it right. We're trying to figure when B is going to be less expensive. Okay, so we want this to be less expensive. Now you're saying, well, it's less expensive right away. You're correct, but we want to figure out for how long. Okay, so where's the breaking point, the boundary point that it's less expensive? Why is it not equal to? Yeah.
You don't want to find when they're equal, you want to find when B is less expensive.
Exactly. It doesn't say when they're equal to or less. It says, or it doesn't say at least. Okay, it's saying less than. Okay, perfect. So we're going to solve this now. So we will minus the 8n, so we get 7n less than 42. Divide 7, n less than 6. Okay, so at 6 hours, they're equal. So everything less than 6 hours, you want to go with option B. Everything less than 6 hours, you want to go with option B.
Well, anything less than 7.
Nope, because 6 hours is equal to. If you play 6 hours, so if you go,
Oh, yeah, I see it.
yeah, it's 6 hours of equivalent in price. I minus the 8n to the 15n. Okay, everything else good? C, okay, everything else down here? Okay, so write that sentence down there. So that means that less than 6 hours, you go with option A, or is it option B? Option B, sorry. And then option A if you go more than 6 hours.